Okay, welcome back to C# application development. This is going to be the penultimate video in this week's module. I kind of want to do a really kind of quick academic sort of introduction to LINQ, and then we're going to look at a lot of examples kind of in practice next week when we talk about persistence. So what the heck is LINQ? It stands for Language Integrated Query. And basically what it's going to do is it's going to let you do a lot of the stuff that you would previously use SQL for, but you can do it on in-memory data using C#. So the most obvious use for something like this is filtering a list, but you can actually combine it with Lambda expressions, and you can do pretty much 90% of anything you can do in standard C# syntax with language integrated query. So we're going to go through several examples of LINQ, and it's basically going to be introduction by example, just to kind of give an idea of what we're even talking about. So in this example, what we've got is we've got the numbers 1 through 10. It's all expressed inside of a list. So this is stored in memory. And then in our main method, what we can do is we can get the evens out of this list by simply querying for the evens. So what I have is a select statement with a from, and that from gives me an iteration variable inside of my enumerable list here, and a where clause that lets me filter that list. So this is kind of the most common use case. You can see how powerful this thing is. You could filter on all sorts of different things. And you can do it on types that are more complicated than just integers. So if you had a whole bunch of objects inside of a list, so for example, in our previous example, you'd have a bunch of classes and they belong to semesters, you could use LINQ here to do that. You would just filter on an ID, a semester ID, passed into the method. So this is kind of a trivial example of how to filter a list just for evens. You could also do something like getting the evens in reversed order. So this is very similar to an order by statement in SQL. And here what we're doing is we're ordering by the variable, but you could also order by a property on the variable, and you can use the word descending if you want to do it descending. The default is ascending. You can also do things like dynamically generate strings. You could also dynamically generate a list of objects. So here, this select keyword is being used to generate a list of strings, and the string is being interpolated using the from iteration variable. So here what we're doing is we are creating a list of strings, and each of those strings is number colon space and then the actual number. So instead of just printing the even numbers, here what we're doing is we're printing the word number colon space and then each of the even numbers. So there will be 10 number string literals, followed by 10 colons, followed by 10 spaces, followed by the numbers, well, 5 of them, followed by the 5 even numbers from 1 to 10. You can also use this to aggregate values. So it's very common that you need things like sums or averages or counts. You can actually use these things to build whatever complicated aggregation you want. And the easiest way to do this is by creating the list first using LINQ, and then off of the enumerable class, you have access to a whole bunch of methods that do common things like sums and averages. So if you're trying to build something like Canvas and you're trying to return an average of a set of grades, you can do that without any calculation on your part. You can just use the average method, and you can make sure that you're getting the correct classes, the correct objects or assignments using LINQ. So this filter process, or the filter kind of pattern, comes up over and over, and this is another kind of key way that you can use it. So we've talked a little bit about how this is very, very similar to what you would see in a structured query language. So something like T-SQL for Microsoft SQL, or something like PostgreSQL. And we're going to look at that specifically next week. So what next week is a kind of crash course in Microsoft SQL. We're going to start with T-SQL and kind of all of the high points of it. And then we're going to take that into our Visual Studio solution and build database solutions, and then build entity framework components on top of the database components. So it's interesting to think that a lot of the same things that you can do in the database on the database server with T-SQL, you can actually do with LINQ, a LINQ query on the application server. So depending on sort of what you're doing, the application, the resources that you have available to you, potentially it makes a lot of sense to get a large amount of data from the database server onto the web or the application server, and then start doing your filtering if you're going to make multiple calls. So that you're not going to the database server over and over and over again. You can store or cache that data on the application server, and then send smaller and smaller pieces, or smaller and smaller lists, filtered lists, back to the caller. So we're going to look at a whole bunch of different examples of using LINQ in next week's lectures, when we actually start reading stuff from a database. We're going to show that we can do a lot of stuff in SQL. We can do the exact same thing in LINQ, but I wanted you to kind of have these examples to look over first. And the similarities between SQL and LINQ don't really stop at the kind of base level. So one of the core things that you can do in SQL is group records and then aggregate over those groupings. And so if we start with a list of something like students, so here I have a student class, and I have a name and I have a classification. So this is a freshman, a sophomore, a junior, and a senior, for example. What I can do is I can do something like select each of the students in the group of students, but I'm going to group them by their classification. And so what this will do is it will return to me a key value pair, and the key will be the name of the student, and the value will be the actual group, or it's the name of the group and the actual group. And so what we're doing here is we're looping over each of these student groups that is created by grouping my students by classification. And so if you go back here, you can think John and David and Laura will all be in the same classification 1. Jane will be in her own classification 2. Bob and Mackenzie and Jack and Diane will all be in classification 3. And then Sue and Mark will be in classification 4. So if I print those groups using the key and the count, I will get 1, because that is the classification that I'm interested in. This is freshman, this is sophomore, junior, senior, and you will find that I have the count of how many people are in here. I could just as easily have looped over that group, and instead of getting the count, I could have gotten the name of each of the people. But you really, the sky is the limit. You can do whatever you want to with these groups, exactly like you could do in T-SQL. So the really, really important kind of powerful stuff happens when you take LINQ expressions and you combine them with Lambda expressions. So each of the enumerable list types, so we're talking about list, observable list, collections, all sorts of stuff. They expose an API that is right off of that class, and it's based on what are called method groups. So what you can do is you can actually pass a Lambda expression into each of these methods, and you can replace a lot of the kind of core functionality of the C# language with just Lambda expressions and these LINQ APIs. So what we're talking about here is basically replacing anything that is a loop structure that can be done with something like the for each method in the API. anything that we could do with a LINQ filtration kind of pattern that we've been talking about in this video, we could do that with a where clause or a where call to a where method. The any method, what that does is it tells you if there are any things, any items or entities in that collection that meet some criteria. So you can pass this a lambda expression that gives you some Boolean condition, and so then it will tell you if there are any that meet. And then we've already talked about first and first or default. So first and first or default largely act exactly like any, except instead of returning to you a Boolean value, it returns to you the entity that meets that criteria, or it returns an error in the case of first if it doesn't find anything. It'll return a no elements error. So examples, this is an example of first and first or default. Again, the primary new thing is we're actually talking about this lambda expression syntax here. And so S in this case is some element of students. And what it's going to do is it's going to find the first one that has the name Laura. And here we're also using string comparison. We're saying that we don't care what culture the keyboard is in. We don't care what the case of the characters are. So the difference between this one and student 2 is if we don't find any students named Laura in the first case, we'll get an exception. If we don't handle the exception, then obviously the method is going to stop processing at this line, and then we don't necessarily know what's going to happen next. Student 2, what will happen is it will return you the default value of a student, and we know that to be a null pointer because this is a reference type. So any, what this is doing is if you pass it nothing, so this is basically just a blank lambda expression, it will tell you if there's anything in this list at all. So this is equivalent to checking the count on students and then making sure that that count is greater than 0. This is exactly the same thing. In this second case, what's happening is we're checking for some element of the list, we're calling it S, and we're making sure that some element of the list has classification equal to 1. And so we've called that freshman in our example. And so here, this will return true if there is some element in the list that has classification 1. If every element in the list has classification that is not equal to 1, this whole thing will return false, and we will never come into this line. So we will only print someone is a freshman if indeed someone in the list of students is a freshman. Where is essentially exactly the same as the any clause, except instead of returning to you a Boolean value, it's going to return to you all of the elements that meet that criteria. So in this case, what we're doing is we're taking the list of students, we're paring that down to only those students that are classification 1, which means that these students will only be freshmen. So here we're just printing that student is a freshman, and we know it's a freshman because we've applied this where clause, and the where is filtering out anything that doesn't meet this criteria. So if you put kind of all of that stuff together, you have the for each method, and what you can do is you can use a standard LINQ query to get a group of students. And then here what we're doing is we are iterating through each of those, and we are adding the students up even over this group by adding the count of each of the groups. So this is basically just a cooked up example to show you that you can combine a LINQ query, even one that has grouping, with a for each on an enumerable list. And what will happen is you can modify things outside of this loop context. So this is functionally equivalent to doing a for each group in student groups and then doing this inside of the body of the loop. So we did that previously. This is kind of the exact same thing in a for each method syntax. So a couple of notes about the benefits of LINQ, and like I said, we'll take a look at some LINQ in practice next week. I just want you to be available or aware that it exists at this point. But LINQ is itself optimized based on tricks that have been used for a very long time in SQL. So it is extremely fast for the amount of power that it has. And unless you have a really, really complicated query that tries to join many different types of objects together, typically this is extremely fast. So if you have the ability to gather a whole bunch of data from the database and cache it on the server, you can use LINQ to query that cache structure in memory, very similar way to how you would query the database, except it is not being pulled from the database to the application server and then from the application server to your client every time. It's allowing you to keep the data that you need a little bit closer to the end user. The interesting thing about LINQ is that the syntax that it uses, once you get over the fact that there is a little bit of a syntactical difference in terms of ordering between LINQ and SQL. LINQ itself tends to be extremely terse. So you can read this and say, oh, well, I'm selecting this thing from some element in some list, applying some filter, and then applying some order. And it kind of makes sense, right? So even people who don't necessarily have a huge background in C# can read these queries and kind of understand what's actually happening. This is particularly true if you're using Lambda expressions, because even though there's no maybe direct comparison for LINQ in something like Java, the Lambda expressions that are used in many of the Java features, especially Java 8 forward, are extremely similar, if not directly comparable to these features in C#. So it helps with people that don't necessarily have a whole lot of exposure to C#. If they have exposure to Lambda expressions in Java, or if they have exposure to SQL, they're much more likely to be able to read and understand your code. And it is terse, so it isn't just injecting tons and tons of code that you have to maintain into the system. The ultimate goal of all of this is that you don't have to continuously write loops inside of loops inside of loops inside of loops and keep track of all of those loops in something like an enterprise controller, which is the last thing that we're going to talk about in this week's module. So the idea behind LINQ is that in 1, maybe 2, maybe 3 lines of code, you can do really powerful data manipulation from a list and get exactly what you want without necessarily going through a bunch of lists and then checking criteria to make sure that you're choosing the one value that you want. And so you can compare this a little bit to the ID finding code that we used in the JavaScript controller to find exactly the one selected semester that we want. That syntax certainly works, but as you go over 10,000 or 100,000 or 1,000,000 records from a database, you want something a little bit more performant, a little bit more terse than that. So this is the 20-minute overview of LINQ. I would take a look at the slides, make sure that you are comfortable with these examples and that you kind of run them in your own solution, make sure that you kind of get what they're doing. The big thing is that we're going to see this a lot, and it's important that you understand that this is how LINQ works, because we're going to use LINQ to create what are called data transfer objects. And if you don't understand that LINQ is kind of similar to SQL, but slightly different, it's going to be a little bit confusing. So I just wanted to introduce this beforehand. So thanks for tuning in, and I will see you in the next video.